bienvenida entonces al Seminario de Educación Matemática. A los que están presentes, muchas gracias por asistir, y a quienes nos siguen por YouTube, también muchas gracias por estar acá. El día de hoy tengo la suerte, el agrado de presentar a Amin. Él es profesor de matemática, es PhD en educación, hizo su tesis de doctorado junto a Gabriel Kaiser en la Universidad de Hamburgo. Eso puede marcar un poco la línea de trabajo, ¿cierto? O a nosotros nos informa más o menos cierto grupo de investigación que conocemos. Ahora trabaja en la Universidad de Oslo, en Noruega, y está haciendo una pasantía, una estancia acá en el CMM de 3 meses, por si acaso, que puede ser un dato también para quienes se interesan en estos temas. Así que, sin más, lo dejo. Algo importante sobre el idioma. Amin habla español, pero no a un nivel que le permita dar cuenta de la difícil teoría con la que trabaja. Por lo tanto, él va a hablar en inglés la mayoría de la presentación, va a hablar lentito para los que dominamos un poco el inglés entendamos mejor, pero si tienen cualquier duda, por lo menos los que están acá presentes, algo que no entienden bien, que quieren aclarar, levanten la mano, pregunten, porque tenemos traductores que nos pueden ayudar a entender un poco mejor ese tema. ¿Sí? ¿Está claro más o menos? Los que están por YouTube pueden dejar sus preguntas en los comentarios de YouTube y las vamos a leer al final, comentarios o preguntas, y al final vamos a dar un tiempo para discutir acá en la sala también. Eso.
Thanks so much, Paul.
You're welcome.
Yes, thank you for having me. And now I start by breaking one of the rules of things that you should never do when you start a talk, by apologizing first of all, which is, I'm sorry that I'm not able to speak in Spanish to you. Yeah, as we have many skilled persons in this room that are multi or bilingual at least, I hope we can manage anyway. Right, let me quickly say a few words about how this talk came about. Salome and Pau asked me what I was doing, which methodologies I applied in my daily work, and here is me talking exactly about this, which is classroom observation instruments, mainly in a quantitative sense, and the theory of the generalizability theory is a statistical or a measurement tool to analyze data that, for example, stems from classroom observation. And this talk is not so much a research talk in the sense that I present to you empirical data from a study, data that I collected and then analyzed and then draw some interpretations from that, but rather introduce this method to you, which is maybe meaningful for certain amounts of measurement problems. Right. A typical situation that we have when we do classroom observation, in a quantitative sense again, is that we reduce complexity, right? So if you imagine this scene in the classroom, then we would imagine there is a certain amount of noise, people talk with each other, the kids look at the screen of this laptop, they see stuff, they discuss. All these things in the end are put into a certain number, right? This is definitely some kind of reduction of complexity. So, and we could say that the quality of this measurement process is determined by how much of the information that we are actually intending to capture is still contained in this number, and how much information of the sort that we are interested in are we losing, and how much information is maybe due to error, bias, some kind of noise that we collect along the way. And generalizability theory or other measurement tools are meant to, well, first of all, determine how much information is in this number or in any kind of number, and also to determine the quality of the measurement process itself, like reliability, for example. Let's start with an important concept that stems from generalizability theory. We have the concept of a universe of generalization. A universe of generalization refers to a set of observations or measures that we potentially could collect. Right? I know this is a very abstract way of thinking, so let me give you an example that is depicted here on the slide. Let's imagine we want to measure the skill of adding two-digit numbers. Right? So we have a person, maybe a kid in elementary school, and we want to know how good is this kid at adding two-digit numbers. Right? Then the set of all possible observations that we could ever have in measuring this the skill is determined by the number of pairs of two-digit numbers. No? Then we can discuss about whether we want to take all of them or only, up to permutations. But you can kind of imagine that the skill of adding two-digit numbers is kind of the average of all of these addition problems, right? If we knew how well a person would be able to solve all these addition problems, we kind of knew what we want to know, namely the ability of the person to add two-digit numbers. Right? In reality, of course, we wouldn't bother not for the sake of ourselves, but also for the sake of the person, by giving them all these addition problems. But we would typically take some kind of subsample of all these pairs, right? We would give them 30 problems, we would give them 40 problems, maybe whatever, and then estimate by, for example, counting the number of correctly solved problems, estimate the overall capacity of this person to solve two-digit, to solve addition problems of this sort. Right. So what we have done now, basically, and that's the main idea, and maybe the main concept that I wanted to introduce, is that we took this measurement process, or this measurement problem, and out of this made a sampling theory problem. Because we sample from this universe, from this, say, population, if you will, of addition problems, a certain amount, namely the one that we give to the person to estimate their skill from, and we kind of hope, or we claim that this set of addition problems that we give to this person is kind of representative to this universe or to this population of all addition problems there are. That's the main idea. And that's what we do now for classroom observation, which is a tad more complicated because this universe of generalization is determined by several things, and I divided the next slides into a number of questions, and we will look at this or possible universes of generalization for classroom observation by looking at the why of measurement, like why as a question, I mean, okay. The what, the who, like who does the measurement, and yeah, I put where and when, but we can more generally say the context of the measurement. That is, of course, also important. Right. So why are we doing classroom observation? And how does that relate to the number or the set of observations that are potentially relevant to us? Let's assume we do classroom observation because we want to give feedback to a teacher about a specific lesson, right? A specific lesson, a teacher asks us to provide them feedback for a specific lesson. Then only the behavior, only the practices, only the interactions within this certain lessons, within this certain lesson is relevant for us, for this measurement problem, right? Because we only give feedback about this lesson, not about the lesson before, not about the lesson after, but about this lesson, right? Let's assume further now, so that this is one. Let's assume further now, we have a program in teacher professionalization and development. We give, for example, a workshop, an ARPA workshop, maybe. And this workshop has a certain period of time and say, for example, consists of a specific set of lessons, and teachers teach during the workshop for a certain amount of lessons. Then the period of time during the workshop is, of course, containing the observations that are relevant for us for this measurement process. So as we see already, the universe of generalization, the set of possible observations that we want to make claims about, is very different. One lesson, several lessons, maybe several weeks. And then we can look into a third example. There are possibly more, these are just three. The one that I'm most familiar with is the third one. For example, we have conducted a study where the goal of the study was to explain student achievement, student learning in mathematics over 1 year of schooling. Then, again, the set of possible observations, the set of teaching practices that are relevant to us are all practices during that year of schooling. And we can imagine that our instruments, our observation systems, our frameworks, our methods have to align with that specific purpose. It's a very different thing to give feedback for a specific lesson in comparison to discussing like what has happened during 1 year of schooling. Good. That's the why. Let's talk a bit about the what. This is an example from a rubric from, we could say, this is an example of an item from an observation instrument that we developed back in Hamburg. We could have other examples, of course, and you are probably most familiar with several different items or several different dimensions of teaching. We could think of classroom management, for example, as a thing that people often look at if they do classroom observation. We could discuss something like positive climate, like how well students feel in the classroom, how motivated they are, how engaged they are in the classroom, how cognitively challenged they are. So there are certain amounts of things that may be relevant to us and others are not, right? And these classroom observation instruments often contain a certain amount of items that are then further specified or laid out, let's say, in these kind of rubrics, where behavior that is interesting to us, that is meaningful to us, that we wish to measure, is explained in certain amount of indicators and in a rating scale usually, right? It doesn't have to be like this. I just this is an example, but this is typically how classroom observations in this sense are conducted, right? Okay, this example is about teachers' mathematical correctness, so it's taken from an instrument that specifically looks at mathematics instruction. Of course, there are instruments that are interested in, or let's put it differently, are not interested in specific subjects, but collect data from all sorts of subjects. Then, of course, you need to ensure that that your instruments work similarly well across these subjects, and that you can actually use the instrument on all the subjects that you wish to investigate. Good. That's the what. Now about the who. Classroom observation is usually done by trained observers or trained raters, which is saying that you train a specific set of people in using a certain instrument, for example this one, and then you make the claim that whether you take one person from the set or another person from the set doesn't really matter anymore, right? You must make this assumption, of course, at some point, because just for pragmatic reasons, you will not be able, usually, to have one person or two persons make all the observations that you want, and if so, you run into the problem that you're kind of relying on one person with all your results, right? So objectivity is of course the point here, and then people do all kinds of inter-rater agreement or inter-rater reliability analysis, and that is maybe the first, maybe less interesting point in this category. That usually you have to make sure that if you do these kind of classroom observations, you do not rely on the judgment of a specific person. And then if you run into this problem, what many people do, you of course will try to either retrain your set of raters, or do all sorts of statistical techniques to average out that several raters maybe are more lenient and maybe some others are not strict. The maybe more interesting case of the who question is if you compare different sets raters. Here in this example is from the paper by Anna Pretorius and colleagues that has been published. Can I read this? I guess it's very small. Sorry. Some 10 years ago, they compared observations by, as I said before, trained observers that has, I think those were students, prospective teachers, or education research students. Then untrained students and teachers, and compared the results. Right? And in this specific study, it turned out that the teachers were best at observing classroom management and learning support, but there are definitely studies that report the exact opposite, right? Yes, because of course, and that's what they argue also in the study, when you do these classroom observations, give or take the rubric, people often still rely on their personal understandings, their personal beliefs, their personal experiences of teaching and learning. And that, of course, sneaks into the process of measurement too. Good. The context. We could talk for ages about the context. So I will only give you one example, to be fair. We could talk for ages about the context. What is depicted in this figure is a result from a study that we ran, where we collected classroom observations over the course of 5 months. So the x-axis is 5 months, 1 month, 2 months, and so on. And the y-axis is the rating scale. So the rating scale went up from 1 to 4, 1 through 4. And the different colors, or the different lines, let's say, are just different dimensions of teaching quality. So then you see that over the course of 5 months, there is already some kind of variation, and especially for the orange one, which is student support or personal learning support, if you will, it kind of went up. So you could argue that there is some kind of a rater drift over time. Raters got more lenient, more lenient, more lenient, more lenient, more lenient, right? Or less strict. So, and of course, this context, if we think of other examples, is always important for the set of observations that is relevant for us. If we go back to the example of different subjects, then of course, if we wish, for example, to look into mathematics mathematics classrooms, mathematics instruction, then we want to specify our instruments towards mathematics, because we will be closer to the learning processes that evolve in the classroom if we do so. On the other hand, then, the behavior of the teachers that we observe in their other subjects is not relevant for us. Good. So what we have seen in the last slides has been a way of determining relevant behavior for classroom observation in terms of why do we do the observation, what are we willing to measure, who is doing the measurement, and the context of measurement. Here's an example. Again, from a study that we ran in Hamburg, where we collected data from 38 classrooms, mathematics classrooms. And this is about the data structure. So, for every classroom, we collected data from 2 lessons. Every lesson was divided into 4 lesson segments of equal length, because in our federal state, lessons usually last 90 minutes. Every segment is up and about 22.5, right? So, and every segment was rated by 2 raters. So, if we want to make claims, as in our case, about learning in this classroom over the course of 1 year, we aim at estimating the overall teaching quality, if you will, or teaching effectiveness in this classroom over the course of 1 year. But what we actually measure is then not only variability between classrooms, between the 38 classrooms that we collect, but also variability within classrooms, which is differences in teaching between those 2 lessons, differences in teaching within those 2 lessons, and also differences in rating between the 2 raters. So this is all kind of contained in this number. Okay. I won't go into the statistical details here, but we could look into an example how we can make sense of results of this sort. Otherwise, anyone who's familiar with an analysis of variance or with a simple linear mixed model, this is basically the theory behind this. So, on the left, we have kind of the same terms as before. Note that classroom is aula. So we have classrooms, lessons, segments, raters, and then we estimated the weird interaction effect that I explain in a minute, and everything else that we cannot make sense of. The abbreviations on the top that you can maybe, again, sorry, not read, is the 4 dimensions of teaching quality that we looked at. Let's, for example, or for simplicity, only take the first column, which would be classroom management, CM, classroom management. Then this analysis tells us that out of the 100% variability that we have in our data, up and about 50% goes back to differences between classrooms, which is nice, because this is what we intended to measure, right? So half of the variance that we have in our pot is due to differences between classrooms. However, on the other hand, on student support, in the second column, it's only 70%, meaning that the variability that we actually have is not due to the differences between classrooms that we intended to measure, but more so due to differences within lessons. Because in the segment row, you see that in parentheses it says 70% of the variance is due to variance within lessons. Right? Unfortunately, we don't have many rater effects, which is nice. but not necessarily the case, and maybe we are just lucky, if I am completely honest with you. Yeah, but just to give you an example how to read such results. Good. And now I already come to kind of my last slide, because I want to tell you what you can do with these results, because they serve, in my opinion, 3 different purposes. Purpose number 1 is you see kind of depicted the information, or decomposed the information that is in the numbers that you have collected, or that you have reduced your beautiful classroom interactions to. That is kind of shown here. That is one thing. Then the second, and maybe boring but also very important thing, is that from this you can calculate certain reliability coefficients, because as you may know, reliability is just information that is important and useful to me over all information there is. Right. So, for example, if in this case the information that is important and useful to me is the differences between classrooms, then the reliability for classroom management and for the third and fourth dimension is kind of good, or at least acceptable in social sciences, not in natural sciences, in social sciences. And the reliability for student support or personal learning support is not so good. Up and about 0.5, if I might remember correctly, and the others are up and about 0.8, just to give you a certain number. Now, I said there is a third purpose, or a third way of making sense of this analysis, and this is planning for future studies. Because if we know what has contributed to variance or to variability in our study, we can adapt our study design towards making more reliable observations. How can we do this? Well, if a certain source of variance contributes a lot to the total variance, we can in a second study, or in a second study, collect more data of that case, more observations from that source, and so control for measurement error towards this source, right? Let me give you an example. The lesson facet, that is differences between lessons within a classroom, contributes by 10 or 11 and 15% in the latter 2 dimensions, which is quite a bit. So we could argue, okay, we want to control better for this variability, because again, we are not interested in giving feedback for a certain lesson, but we want to have a stable measure of teaching quality, because we want to talk in this study about teaching, like average teaching quality across a year of schooling. And then we would have to collect data from more than 2 lessons in order to control this source of variance better. On the other hand, for classroom management, that doesn't make sense, because it only contributes by 1% up and about. And this means that by collecting more data collecting more lessons, we cannot improve the reliability for classroom management in a meaningful way. And the same holds true for raters, since raters fortunately do not contribute much to variability in scores. We do not have to collect, or we maybe should not, speaking from an efficiency standpoint, should not train more raters, because this will not improve the quality of the measurement process. Right? This is very, here you sometimes in publications see these kind of graphs. So what is depicted here on the y-axis is the reliability, and on the x-axis, this is a different study note, please. On the x-axis is the potential number of lessons that we could collect. And the graphs show the improvement in reliability if we collect more lessons for these different teaching quality dimensions. So we see that for some of them, the one above, they're kind of very good already, so they cannot be improved much by collecting more data. However, the one in the bottom can be improved quite drastically only by collecting 1 or 2 more lessons. And this is kind of interesting if we plan for future studies, because sometimes always we will be held back by our, let's say, financial resources, for example. So we have to argue whether we want to, for example, train more raters, collect more lessons. Maybe we cannot do all of that, but maybe we can find an efficient improvement of our measurement process by doing only some of those. Right, let me stop here, and thank you very much for bearing with me, although I didn't switch the language. Thank you.
Bueno, vamos a abrir entonces las palabras. Yo propongo quizás que preguntemos en español, porque así podemos integrar a todos quienes les haya sido difícil seguir la presentación. ¿Sí? No sé qué les parece. Y Fernando, que es un profesional en ambos idiomas, un nativo en ambos idiomas, puede ayudarnos haciendo la traducción. ¿Les parece? ¿Estaría bien eso? ¿Sí? Bueno, abrimos las palabras. En YouTube no tenemos preguntas, pero todo lo que hablemos se escucha perfecto, así que tenemos un micrófono ambiental.
Yo tengo una pregunta. Sobre la última parte, que hablaste de la confiabilidad que iba mejorando a medida, o sea, ese análisis de la confiabilidad y cómo mejoraba, pero me queda la duda de que cuando la confiabilidad es alta, o sea, como que uno está seguro de que el puntaje representa algo, en este tipo de mediciones en que yo quiero ver la calidad, también está esa discusión de que yo quiero que varíe porque quiero ver si es que hay una mejora cuando hay ciertas cosas o empeora bajo ciertas otras. Por ejemplo, si un colegio está cambiando la manera en la que hace las clases, poder medir si es que eso mejoró la calidad de la clase o de los segmentos de las clases. Y eso afecta la confiabilidad, entonces también pienso, si es que es muy estable la medida, ¿está realmente capturando la calidad de la clase o quizás es muy robusta y eso no permite como medir algo interesante en términos de cambios de calidad?
So the question has, la traduzco si la medio barro correcto.
Yeah. No, please. I'm sorry. I just didn't get the last part. I think that the full question.
So the question has basically to do with the fact that if we already have a very reliable test,
yes,
and it's very static,
yes,
that level of static could in fact be a hindrance, because if we really want to measure kind of the implications of what it is to change, for example, a research methodology, a teaching methodology, what do we do when something is already very static? How can we actually observe it?
Good point. Good point. I agree with you. I agree that the point where something is very static is not the most interesting or the most that we can optimize our measurement for different purposes as well. So this analysis doesn't have to stay at the static part. They only did this graph for a certain purpose. Like if we go back to this slide, then maybe we have found a great way of measuring a certain lesson. We have found a great way of estimating the certain teaching quality for a certain lesson, but maybe not so much for the long term. And this analysis can be done for different purposes. It's kind of you can think of this as a simulation analysis actually, because these are hypothetical lessons, right? It means that if we had observed 10, 15, whatever lessons, then this would come out, given the conditions of this study. However, we can do this for different kinds of purposes, right? There they check the quality for the number of lessons per teachers. So apparently they were interested in measuring some kind of stability. But you could do the same for raters. You could do the same for items, if you will. Maybe your instrument is supposed to measure some kind of overall ability, and you need a certain amount of items, and the items are maybe not good enough to capture this ability. So it really comes down to the decisions that you want to take with your measurement. Sorry, this was a very long answer for a fairly short question.
Si quieres puedes englobar la respuesta.
Okay. Entonces, como el hecho es que sí, para un punto de vista, desde el punto de vista de un investigador o de la investigación, lo que es estático tiende a ser un poco aburrido y no tiende a ser tanto algo que uno quisiera seguir indagando. Pero es importante recordar que esto midió uno de los aspectos, de la cantidad de posibles aspectos que uno puede llegar a querer medir. Entonces, si bien en este momento parecía que está como saturado, uno podría regresar a otras de las premisas de la investigación y preguntarse más bien por qué más podríamos hacer o qué otro aspecto es el que quisiéramos realmente estar evaluando.
Mi pregunta va relacionada a que yo de partida agradezco la presentación y comparto la última parte que decías que claro, en el fondo en el contexto real lo cierto es que tenemos muchas limitaciones y no siempre podemos ampliar ya sea el número de observaciones de clase o la formación de observadores de clase. En el fondo no podemos estar controlando todos los ambientes cuando tenemos en el contexto real, ¿cierto? Entonces mi pregunta iba relacionada un poco a la tabla que había mostrado respecto a la variabilidad en los distintos elementos de la clase, ya sea entre clases o intraclases. Y mi pregunta era, ¿qué recomendación harías tú en el fondo en un proyecto que tiene más limitados los recursos? ¿En qué tipo de variables nos centramos? ¿Nos centramos en observar más clases, en formar más observadores, en más segmentos?
Good question.
Sintetizando un poco la presentación.
again, this is kind of the beauty of or maybe it's not the beauty, it's you are kind of free in your choices, and that is kind of the thing that you have to kind of take care of, you know. So this kind of analysis asks you kind of to think very clearly before you want to collect your data, like which observations or which behaviors are meaningful to you. So if, for example, in the end you want to make the claim that your observations are not dependent on the observers, then at least you should hire a couple of observers to investigate the claim. And of course, if you want, I mean, that is clear, I think, but if you want to look at variability, you need at least 2 instances of everything to do this kind of analysis. But the same holds kind of true for lessons or time-based variability. If you want to have a stable measure, or you're interested in a long-term behavior, you have to collect measures over time to make sure that, or to investigate at least, whether you have the stability in your measurement. If that's not important to you, because, for example, you look into a specific lesson, you do not have to collect data from several lessons. You only have to collect data from this lesson. That being said, of course, we all know that instruction, teaching, and stuff is a very interactive process. There are many, many different things going on. And going back to this idea of reduction of complexity, we of course have to think about like which of these interactions or which of these context effects may possibly affect our measurement process. Like, is the subject meaningful to us? Is the time in school, during the school year, important to us? So there are some studies where they show that just over a school year, teaching quality varies quite a bit. Like teaching right before the holidays, summer holidays, or right after the summer holidays is not the same as the average teaching, something like this. So, yeah, it really comes down to what you're interested in and what you want to capture.
Un poco en resumen, como este tipo de investigación, este tipo de aproximación a la investigación realmente te obliga a ti como investigador a tener una claridad sobre qué es lo que tú quieres observar. Porque en efecto no hay realmente una respuesta como para esta pregunta. Entonces, si lo que quisieras observar es qué tanto afectan los observadores, tu foco tendría que ser en incluir observadores, y recordando siempre que se requieren mínimo 2 interacciones para poder medir la variabilidad. Si lo que tú quieres es medir qué tanto afecta el tiempo en las lecciones, entonces tendrías que incluir mediciones sobre el tiempo. Entonces, digamos que la respuesta es, le regresa la obligación un poco a los investigadores y a las investigadoras, y a que tengan conciencia sobre la claridad en qué quieres medir, porque lo que quieres medir es lo que va a realmente decir que dónde pones el tiempo y las lucas.
Nice.
Yeah? Doing good?
Yo tengo una pregunta. Quisiera saber cuánto pesa el marco teórico que hay detrás de una pauta. Porque, por ejemplo, estaba pensando yo en la dimensión Learning Support. Dependiendo la perspectiva teórica con la que mires o entiendas el aprendizaje, ¿cierto? Desde marcos más constructivistas, marcos más socioculturales, la manera de apoyo del profesor esperado, lo que sería bueno, adecuado, lo que definiría el nivel máximo, el nivel 3, es distinto. Entonces, ¿cómo se define eso? ¿O cuánto pesa la mirada teórica que hay detrás de la construcción de la pauta?
So the question is that how much does the underlying principles of a learning theory affect the way you measure things? So, for example, if you take a social constructive approach to it, the underlying principles of a social constructive approach are not necessarily the same as, for example, a conductivist approach. So when you're designing the rubric and then you're implementing the rubric, you have two very different underlying philosophical approximations. How much does thus affect the actual measurement?
Hugely.
Enormemente.
You know how I know? No, I don't. No, I don't know, but I would. This is at least how I interpret what I read in the literature, because there are oftentimes studies that are conducted in a very similar way, with a very similar design, and they name their dimensions, items, whatever, very similarly. But if you really look into the details, they sometimes come from different theories, or they conceptualize at least the facets of teaching that they look at differently, and then they end up with completely different results and wonder why. Right?
O sea, él dice que mucho y la manera en que puede llegar a esa conclusión es que en la lectura que él ha hecho de la literatura que existe en este tema, hay estudios que cuando uno los lee, si quieres, como de manera transversal o transversal, nunca sé si es tras o transversal, pero cualquiera de las dos, pareciera que son idénticos, ¿no? Es exactamente casi la misma manera de nombrar los ítems, misma manera de nombrar los pasos, pero a pesar de esa excesiva similitud, acaban siendo resultados completamente distintos y luego se pregunta a la gente ¿por qué? Y la respuesta es porque evidentemente el peso de la teoría del aprendizaje es completamente distinto.
And of course, I think the theories can also come into play in the period of time that is important to you when measuring teaching. Maybe sometimes, or maybe for some facets of teaching, it's more important to look at a long-term behavior than for others. If you look at disciplinary things like classroom management, also studies show that it's often enough to observe one lesson and you kind of already know the long-term behavior, more or less. Not of a specific teacher, but for a whole study. And then if you look at other things, it's not the case.
Y esto también obviamente está muy ligado a la manera, o sea, está ligado a la temporalidad, pero porque la temporalidad a la vez está ligado también a las teorías de aprendizaje específicas, ¿no? Entonces, por ejemplo, si lo que quieres observar es netamente disciplina y tu concepción de disciplina es mucho más como conductista, podría uno decir que menos observaciones bastarían porque realmente no estás intentando evaluar el desempeño del docente, sino realmente solamente la medición de una conducta. Entonces, no nada más es importante la teoría, sino también es importante cómo la teoría está proyectada en el tiempo y cómo esto juega con lo que uno quiere medir.
¿Más preguntas? Bueno, entonces podemos cerrar hasta acá. Le damos las gracias a Min. Muchas gracias a Min por hablar lento. Yo por lo menos pude entender bastante. Y eso, muchas gracias. Y les recuerdo que Min va a estar haciendo una estancia por un tiempo más, así que va a estar disponible acá en el CMM para todas las personas que trabajen estos temas, que yo sé que algunas estaban en YouTube mirándonos. Así que eso, muchas gracias por venir.